Hi, welcome to the Smart Network Management for Water Utilities webinar, and thank you for joining us today. My name is Lori Armstrong. I'm Esri's Global Industry Manager for Water and Wastewater. Joining me today is Chris Stern, Director of Strategy and Portfolio Development at Trimble Water, Mark Townsend, Assistant Director of Information Technology Services at the City of Los Angeles Department of Water and Power, and Adrian Newcomb, Head of Software Engineering at Trimble Water. Chris, Mark, and Adrian are going to talk about how the City of Los Angeles' Department of Water and Power implemented Esri and Trimble technology to help manage their utility. They will provide an overview of the benefits of smart network management, illustrate the Trimble eRespond water incident management software, and Esri's ArcGIS for water utilities. They will discuss the implementation, the challenges, and the benefits of these solutions. If you have any questions during the presentation, please submit them via the GoToWebinar question pane, which will be answered at the end of the presentation. I am now going to turn you over to Chris. Chris?
All right, thanks, Lori. So for today, we have a three-part agenda. First off, let me welcome everyone on behalf of Trimble and Trimble's global water business. I've personally been involved in this industry for close to 20 years in utilities and IT and seen a lot of challenging projects. So I'm excited today that we have Mark Townsend of LADWP here to share his experiences on one of the more progressive projects I've seen in the industry, along with Adrian Newcomb, who I consider one of the industry's brightest software engineers, to provide an overview of the software and the technologies involved in the implementation. The three-part agenda will start off with an overview of smart network management, what it is and its value for water utilities. In the second part, we'll have an overview of the implementation at LADWP of a smart network management solution, and Mark Townsend will give an overview of the LADWP business, their water operations, discuss the project drivers and requirements, and walk through their solution and the deployment process. Adrian Newcomb will fill in the details on the technical aspects of the software and the system architecture. Then Mark will wrap up with a summary of the lessons learned and the next steps. So the final stage here will have lessons learned, and Mark will pick that up and cover the next steps for LADWP, followed by wrap-up and question and answer. So let me start off with an overview for everyone here on the next slide on what is smart network management. What I want to do here is hopefully get everyone on the same page with the business value of what we're presenting today. As the title implies here, we're presenting a project in the context of smart network management for water utilities. So what is smart network management? Simply put, smart network management applies technologies to a water network to improve and fundamentally transform water management. For those familiar with the electric industry, smart network management applies the electric smart grid concepts to the water industry and to water networks. So they apply to the concepts of supply and demand management, prioritizing aging infrastructure investments, improving productivity, enhancing water quality, health, and safety. Smart network management integrates three core technologies illustrated in the bottom of this first slide. One, the deployment of field measurement and monitoring sensors and devices, including pressure flow and water quality monitors, smart metering, GPS, and RFID to water network assets and workers. Two, coupling those real-time sensors with intelligent GIS-enabled network management software, both cloud, office, and mobile. And three, enabling visualization and informed proactive analysis and decision-making through intelligent control and advanced analytics. Smart network management fundamentally transforms water operations by helping utilities remotely and continuously monitor and diagnose problems, prioritize and manage customer and system maintenance issues, and use maps and data to optimize all aspects of network operations. In today's presentation, we'll give an overview of how LADWP's project has helped them advance a smart network management approach for managing planned and unplanned incidents across their water network. The value of smart network management is compelling, and I think you'll see from our upcoming presenter. According to a recently studied commission here, it was noted that smart network management could save the world's 180 largest water utilities over $12.5 billion every year. Savings were noted in these four areas shown on this slide: leakage and pressure management, strategic capital expenditure prioritization, water quality monitoring, and network operations and maintenance. So what that means for utilities of all sizes is that there's substantial benefits in deploying these solutions. Also, from a technology perspective, what's important to note, and what you'll learn today, is that an incident management solution highlighted in the lower left corner here on the slide as Water IMS is an essential part of achieving these benefits. So for LADWP, what you'll hear from Mark Townsend is how their water department implemented an enterprise water incident management system using Trimble and Esri technology to help with leakage and water quality management and improve their overall network operations and maintenance across their vast service area in the city of Los Angeles. So with that backdrop, I'll hand it over to Mark Townsend from LADWP now to give an overview of their implementation. Mark?
Thank you very much, Chris. My name is Mark Townsend. I work for the Los Angeles Department of Water and Power, and we are a municipal utility serving citizens of Los Angeles. The Water Department was formed in 1902 to try and resolve some of the issues around water supply within the Los Angeles basin. Essentially, we're a desert, and bringing water in from various parts of the state. We have an annual budget of $4.2 million, which is across the water and the power departments, serving 4 million residents in the city of Los Angeles. Those are divided up into about 700,000 water customers and 1.3 million power customers, with there being some overlap, obviously, between the two. We're also the billing agency for the City of Los Angeles wastewater and refuse, which is run through a different bureau within the city. So the water supply from Los Angeles has some interesting history. The supply is brought in from well, 4 major sources. Just prior to World War II, the Los Angeles Aqueduct was built, which brings water from the eastern Sierra down through an aqueduct of about 250 to 300 miles, supplying water to the Los Angeles basin. Following that, it was realized that there was additional water supplies needed, and there was another major project that occurred after World War I, building of the Hoover Dam and the bringing water over from the Colorado River Aqueduct. That then was followed by a third project, a state project, bringing water down from Northern California from the Sacramento River Delta into the Los Angeles area, and it also supplies much of Southern California. We have 7,300 miles of pipe in the Los Angeles basin, serving an area of 485 square miles. We had an existing CIS, customer information system, that was in place, was performing billing for us, and had interfaces to about 30 other systems. This provided billing. We had a legacy water trouble, water quality system that provided some rudimentary support and enabled us to do some correlation of different water trouble problems that different customers were experiencing into events. The project team that we had in order to replace this was 150 staff, comprised of LADWP staff, Department of City staff, a system integrator for the Oracle components of the solution, which included the billing system, a mobile solution, and a meter data management solution, and then 4 other third-party integrators who were supporting various other parts of the solution. We were replacing a 39-year-old legacy system, which was made up of customer information system, a mobile data solution, in-house built meter inventory system, which was based upon a punch card solution, a water trouble and quality system that we had built in-house, and that will be the continuing focus of this presentation. Also, we had a meter reading and route design solution that was built in-house, and we had a Sun JavaCap system that was doing a lot of the integration. That was a legacy solution from Oracle after the purchase of Sun, so we had to also replace that as part of this project. This slide is just going through some of the major systems. If you look at the diagram on the right, that is the interface diagram for the project. We had about 35, I think, different systems that we had to interface into the core billing solution, comprising of almost 60 interfaces, various SOA interfaces and point-to-point interfaces. Listed on the left are the various products that we brought in, including 3 major upgrades around our print-to-mail solution, our IVR solution, and the website. Trimble eRespond was brought in to address water quality, water trouble, and event management where we had planned outages in the future. The legacy system we were replacing, somewhat familiar to the older amongst us, of a TUI interface, text user interface with dark screens, mainframe based. We identified zones in the old, identified events within the old system by looking for commonality of pressure zone and approximate geographic proximity. It gave us a relatively reasonable solution from 20 years ago, but certainly didn't manage to figure out a lot of the problems that we were having. We looked at various solutions. One was to rewrite the current solution, go and look for a package, and we went out and investigated several different packages, and the solution we chose was the Trimble solution. So what we were looking from a business standpoint, we needed a solution that provided at least as good information as we currently had. The old solution allowed the contact center, who had little knowledge of how the water system was comprised or how water quality issues were managed. It enabled them to take customer calls and complaints, and also take complaints through the website, and dispatch them over to our water system, who would investigate them. We needed to have it integrated with the customer care and billing system that we were deploying, and wanted IVR integration as well. The one thing that was we're also looking to do was import the network model out of our Esri GIS solution, so we could do a better analysis of how different problems were on trouble tickets and quality issues were related to each other. That hopefully would enable us to manage restoration time for customers. Go live weekend was about 7 weeks ago. We went live over Labor Day weekend. We brought some couple of pictures of some of the action from Labor Day weekend. We had 2.35 million meters we converted, which included 700,000 water meters. A little shy of 2 million accounts were brought up from our system. We had 12 brand new systems and 55 SOA interfaces, so it was a fairly massive effort just to stand all the new pieces up and get them to connect. We started on a Friday night, Friday early morning, and we had it ready on Tuesday morning after Labor Day. So what we implemented, which we will talk about further, is enabled us to do incident identification and management. The map on the right is showing incident that we had since go live. I believe we had a main leak that caused us to shut off the area identified by the polygon, which had about 24 different customers affected, and the integration between the customer billing system and the eRespond system allowed the agents within the contact center or people coming in through the web to easily identify they were part of a known outage, and were able to see what their expected response time was. Customers could request that they have an IVR callback, and the system would call them back when we felt it was restored, or would provide extensions to the time that we expected time of restoration. So if we look, this is just a couple of screenshots of parts of our customer billing system. This is a customer who was part of that outage, and so it shows clearly that a recent water trouble call existed for that customer. So the agents are well aware of the fact that they're part of a known outage. And the customer callback is in place. So this is a diagram which Adrian's going to go to in further detail, which shows the eRespond system and how that was integrated into the various other pieces of Oracle CCMB, IVR, our GIS system from Esri, and up into our website. And at this point, I will hand it over to Adrian.
Thanks, Mark, and hi, everyone. So having heard about the smart water context and the drivers for the project at LA, let's take a look at what the eRespond product is. So Trimble eRespond manages incidents. An incident is an occurrence within the water network, such as a leak, an outage, flood, or water quality issue that requires action by the utility. eRespond manages both planned and unplanned incidents in an integrated view, providing incident managers with an up-to-date picture of the current incident situation in the network. Trimble eRespond correlates data from various sources, including customer calls from the call center, alarms from SCADA or AMI, and other telemetry to automatically identify new incidents in the network. It allows dispatchers to centrally manage the incidents in their area, coordinate response activities, and track progress and resolution. Through Trimble eRespond, incident dispatchers can visualize the current situation in the network with a variety of views, including spatial map views, tabular grid and search views, and matrix drill-down screens. This allows the dispatcher to review the overall situation or focus on the details of specific incidents and move seamlessly between these levels of detail. We'll see some examples of these views in a moment. A key element of efficient incident management is the ability to analyze where incidents are occurring, the types and frequency of specific incident types, and asset types affected. And this can feed into asset management and capital investment planning. Trimble eRespond provides a range of management reports that aid in this analysis. Most water utilities operate in a regulated environment and must report to the regulator on performance indices, including those around incident management. Information gathered during the incident resolution and tracked within Trimble eRespond is used to prepare such regulatory reports directly from eRespond. For situational awareness, here's an example screen showing a zoomed out map with the current incidents rendered. So you can see the renders, the incidents rendered against that geographical context. As you would expect, there's the ability to turn on and off which features are visible in the map view, as well as filter the information based on details of the incident. And here's an example of the tabular screens within Trimble eRespond. Detailed search facilities on the left pane allow the incident manager to search on incidents and build complex search queries. Results are displayed in the top right, with the specific incident details visible in the bottom pane. Tabs on each of these views provide different operational perspectives to the incident manager. For example, planned incidents, work management, faulted assets, and so on. Here we can see a GIS view of the network assets and the incidents. And again, this is another example of the screen that Mark showed earlier. So again, all the network assets are available to be displayed, and users can filter out the visible features and types of features that they wish to see at any time. So what are the benefits of Trimble eRespond? The key benefits are improved service response. By being able to identify and locate an incident quickly, it means the utility is able to resolve the incident much quicker, resulting in customers experiencing much shorter disruptions and allowing the utility to serve those customers better. Another outcome of the reduced incident times is the reduced losses associated with an incident. For example, this includes reducing lost water through leakage of water or lost revenue due to non-consumption of water during an outage incident. The next and related benefit is the ability to quickly and proactively communicate with customers during an incident. Rapid incident identification allows the utility to indicate to customers calling in that they have identified an incident and that the expected response time is. It also allows proactive communication where the utility may inform a customer before the customer is even aware of the issue happening. This is particularly valuable for key account management. Trimble eRespond provides full situational awareness with GIS-based map visualizations that show what is happening and where. This means that incident resolution and emergency planning and response can be initiated rapidly with clear information on the current situation. Trimble eRespond facilitates better regulatory compliance with rapid incident response, repeatable, trackable resolutions, and full reporting on the incident. Better regulatory compliance will result in reduced fines and/or smoother investment approvals. Trimble eRespond reduces IT maintenance costs as it's a web-based solution that does not require any specific installation or maintenance on users' computers. It has standard interfaces for integration with the main utility enterprise systems such as GIS, Work Management, and SCADA. It's an Esri partner solution and also has certified integrations with both SAP and the IBM SAFE programs. Finally, Trimble eRespond is the only incident management system recognized by Gartner as specifically addressing incident management for water and wastewater utilities. So let's look at the end-to-end business process in the life cycle of an incident. So our first stage is the identification stage. Here, new incidents are recognized through analysis of patterns in the incoming calls and alarms. Such calls and alarms may be associated with existing incidents previously identified. We'll look at that identification process in more detail later. Then the second phase is the resolution phase. Having identified the incident, the dispatcher or incident manager will decide on the response and assign the incident to the appropriate crews for resolution. Crews in the field will collect data and update the incident progress as they work. This progress is tracked by the incident manager and also available to the call center or IVR for communication to the customer. As the incident is resolved and closed, this is again tracked and notified to both incident manager and potentially through CIS to customers. Automatic callbacks can be triggered to customers impacted for verification and follow-up, again allowing the utility to provide a premium customer service. And finally, the reporting phase of the incident begins. Now that the incident has been resolved, analysis of the incident and its responses, as well as trends or overall patterns in incidents, can be performed. Where necessary, regulatory reports on incident performance and individual incident responses can be generated to be included in a regulatory return. Now let's come back to incident identification once more. So the incident identification process is the means by which Trimble eRespond finds new incidents in the network. And it's worth spending a little time on this as it's a key element of the solution. When a new call or telemetry alarm is received by Trimble eRespond, a series of business rules are triggered. These rules look at the current call in conjunction with other existing calls, the current known incidents in the network, and the topology of the network. The rules understand what types of calls or alarms relate to each other. For example, on the same incident, one customer may experience no supply, while another may experience poor pressure. The rules within Trimble eRespond recognize these and can determine if such customers are part of the same incident or not, something we refer to as cause and effect. The relationships between incidents and their alarms and calls is visualized both spatially and in a hierarchical tree view, so incident managers can quickly grasp their locations and their relationships. Where the business rules determine that an incident may be in progress, they also identify the likely location of that incident. Depending on the accuracy of the network model loaded, eRespond can locate the incident to a specific asset, or where the network data is not as good, to a geographical region. For example, at LADWP, we have good network data available for incident identification, and this allows Trimble eRespond to identify and associate an incident to the specific asset within the network that is suspected of being the problem location. Again, as an example, that asset could be a valve or a pipe section within the network. The business rules within Trimble eRespond are native water rules, rather than rules from another network such as electricity that have been repurposed for water. As such, they handle water-specific cases such as the variety of symptoms referred to earlier, and also latency of effects. This latency is an important aspect of incident identification. It may take some time for an incident to propagate through the impacted area of network and for its effects to be noticed. Similarly, when an incident has been resolved, there may be residual effects in the network afterwards, such as discoloration or odor. The business rules understand these effects and incorporate them so that false positive or duplicate incidents are not created. Incident management does not occur in a vacuum at a utility, and it's worth considering how Trimble eRespond integrates into the wider utility systems landscape. So in this slide, we can see a generalized landscape of utility operations from an incident management perspective. We see the usual systems such as CIS, CRM, GIS, SCADA, and CMMS, and also a BI system for data warehousing and analysis. You can see here how Trimble eRespond interacts with all of these systems to achieve its purpose of end-to-end incident management. It integrates with CIS CRM in order to exchange customer details, gather customer calls, trigger callbacks, and update incident progress. Trimble eRespond also has an optional call take module for use by call center agents where a CIS or CRM is not in place, or if the customer does not wish to integrate their current CRM system. Trimble eRespond integrates with GIS for retrieval of the as-built network information used for much of the analysis within the product. GIS is also the source of mapping information, including base maps that are used as part of our spatial visualization in eRespond. SCADA interface is provided to gather telemetry information where it exists, and eRespond uses this both to understand the current network configuration and as an input to incident identification and resolution rules. Trimble eRespond integrates with computerized maintenance management systems for work management and tracking, and this interface can be used for exchange of work orders between the CMMS and eRespond. This standard interface has been certified with IBM Maximo and with SAP. Alternatively, Trimble eRespond also contains an optional work management module whereby all incident-related work management can be handled within Trimble eRespond. Finally, eRespond provides exports of data that can be imported to a business warehouse or data mart for integrated reporting. This capability supports the reporting facilities provided as standard within the application. Having considered the general landscape, let's look at how it translates to the situation at LADWP. So here we can see how eRespond has been currently deployed at LADWP. We have integration with GIS, with CIS CRM, and with web server. More on these in a moment. Work management is performed using the integrated work management module in Trimble eRespond, and the integrated reporting capabilities are used rather than an external BI interface. Now let's briefly consider each of the integrations. Starting with the GIS integration. There's two elements here. Firstly, the synchronization of the network data from GIS. As GIS is the master of the as-built network, it's loaded into Trimble eRespond from GIS and synchronized with updates from GIS thereafter. Thus, it shares its view of the network with GIS. Additionally, GIS provides maps that are the basis of the spatial visualizations provided in Trimble eRespond. Next, we see the integration with CRM and IVR. There are a couple of exchanges that occur as part of this integration, and these include synchronization of customer details from CC&B to Trimble eRespond, passing of customer calls from CC&B to eRespond, exchange of callback requests and responses between eRespond and CC&B, proactive updates of incident status and progress from Trimble eRespond into CC&B. IVR is also integrated as part of this interface so that customer calls originating in the IVR are received into eRespond, and callbacks may also be automated through IVR. And last but not least, to round off the end customer communication, we have an integration to an external web portal where the list of current incidents is delivered to the web server for display on the LADWP web portal. Before I hand back to Mark, I'd just like to take a minute to discuss some important technical aspects of the solution. The user interface is fully web-enabled, and being a thin client web app, it does not require a specific install on a user's desktop. This reduces the cost of installation and maintenance from an IT perspective. The solution is highly scalable from a small deployment to very large. LADWP have over 700,000 managed endpoints in eRespond, while another customer, United Utilities in the UK, serve approximately 3 million premises. Recognizing the importance of integration in its deployment, Trimble eRespond has a dedicated integration module that provides standard interfaces for each of the common integration types, such as those outlined earlier. These use best practice integration technologies such as web services, message queues, and XML. The information model within eRespond is derived from industry standards, and importantly, as part of a water solution, it maps to the Esri local government information model. Now I'd like to hand back to Mark for a synopsis of the project at LADWP and next steps for the solution there.
Thank you very much. So I just wanted to go and cover a few challenges that we ran into. Obviously, we ran into more than three on a three-year project, but these were sort of, I think, the ones that gave us most challenge. We simultaneously implemented 12 brand new systems or majorly rebuilt systems, plus close to 60 interfaces, all on a single big bang go live. We did have some major discussions, and we had some people in various camps of whether that was a good idea or a bad idea. I think the real issue was that if we started breaking it up into pieces, that you ended up with so much throwaway work over the course of trying to roll out all these systems that both the time frame and the cost started to become a little bit unmanageable. But it was a pretty high-risk implementation. We are up and running. I would not say defect-free, but in the case of Trimble, I think we're down to only a few defects. I think they represent about 2% of the total defects that we have in place. So I think it went reasonably well. One of the other things that we hadn't really sort of thought about, which probably we should have, you have the engineers happily building their GIS solution of the network model. You have the customer service division putting together all their billing pieces. In order to make the Trimble eRespond solution, you have to basically plug the customer together with the service point that we're serving them through, and we discovered that we had some service points in the GIS solution that the billing system was unaware of, and we had some billing points, customers we were billing that were missing off the GIS solution. So it took us a little bit to get things in sync. We had several trips to the field by service people over the course of the project to go and actually look at the meter and see what the heck it was, because we couldn't determine what it was based upon our data. And then just sort of a slightly lighter-hearted thing in terms of challenges we had. When we were setting up the load test, we set up the amount of data that we go through in a period. However, the data that was provided was they provided what the load was over a 1-month period, and the person who set up the load test thought that was a 1-day period. So I think we managed to run 3 months worth of trouble calls through eRespond in a 24-hour period. Surprisingly, it worked pretty well. So we know that we are prepared for a lot more load than we actually are experiencing. So those were the challenges. There were other challenges, I think, that we ran into, but I think those are the 3 that I think we're focusing on. In terms of future plans, we have started working on integrating the eRespond solution so that we send the trouble tickets out to the field into mobile devices. The water crews have mobile devices which they are getting some parts of their day's work through at the moment. In terms of trying to reduce risk, we decided not to integrate eRespond into that mobile solution at go live, and to do it in the sort of first 6 months. So that's the first one that's going. We also have an annual regulatory reporting that we have to produce for the state of California on an annual basis. We're putting together those, and that's part of the integration into a BI solution, so we're looking at that. Also, we get one of the things that we did implement when we rolled out this solution is we still have meter readers reading the water meters. They report field conditions they find, such as leak in box when there's a leak in the box, trickle in street. So these various things get reported through the meter reading system. They then come back and are forwarded over to the water trouble system. So there is, if you remember back to the slide where we had all those dots all over the city of Los Angeles, which looked a little bit like Swiss cheese. A lot of those are actually around events such as leak in box or trickle in street. So they're minor events, but we do now have a lot better visibility of what small leakage we have going on, and we're slowly working through those. So those events, as we've now 7 weeks into this, we've pretty much read every meter in the city, so we now know all the meter boxes that have minor leaks or trickles into the street, and running some analytics around understanding what loss we're getting out of those and fixing some of those minor loss. So I will hand it back to Chris, who will, I think, has a final wrap-up and some question and answers.
Thank you, Mark. So we did have a few questions come in through the question pane. For those of you who have questions who haven't submitted them yet, please use the GoToWebinar question pane to submit your questions. So let's get started with our questions and answers. First question we have is, what's the BI system DWP uses?
I guess that would be my question. So we use Oracle BI and OBIE as the solution.
Thank you, Mark. Okay, did LADWP visit other eRespond customers before selecting the product? Mark, you want to take that one?
Yeah, we did. I actually visited United Utilities in the United Kingdom. As you may tell from my accent, I'm not a native Californian. And I went to United Utilities, which when I lived in the northwest of England used to be Northwest Water. I have friends and family in that area, so I went there and visited them and looked at their operation. A lot of the thoughts and ideas that we included into our deployment came from that visit. They run their system a little bit differently than we do, in that they tend to have a specialized part of their call center which is focused entirely on taking customer calls around quality, trouble, and calls, whereas we tend to put the calls into our generalized call center. So agents get billing inquiries and water trouble calls.
Great, thank you. Another question. What model or type of mobile devices are you using in the field? Also, what type of software are you using on the mobile devices?
I guess that's me again.
You're popular.
I guess so. We are using a Scion, and I forget the device number, but it's a Scion device which has about a 4-inch screen. It's a handheld device, very similar to a meter reading unit, and we're using the Oracle MDT software, which comes with Oracle Mobile Workforce Management.
Thank you. What do I need to have to roll out eRespond? Do I need a full GIS? Do I need to interface to CIS to use the software? Adrian, you want to take that one?
Yeah, I'll take that one, Krista. The range of what you need really depends on what you have and what you want. So you can range from deploying eRespond standalone without integration, and you will get the full benefit because of the incorporated capabilities from trouble call through to work management and reporting. Or you can run the full gamut of integration as we've seen in the landscape. So you can integrate with your existing CIS, GIS, SCADA, CMMS systems that you already have. And very often it's somewhere in between those extremes that our customers would place themselves. And again, as we can see with LA, it's possible to deploy it in a phased manner, where you choose 1 or 2 key integrations that you want to achieve, and with the initial deployment, and get that initial business value. And then as you get familiar with the system, you grow the capabilities into the other parts of your landscape.
Thank you.
One thing I'd add, Adrian, to that is that although we deployed our GIS model, I also talked about the fact that we had a mismatch between our billing system and our GIS system. So there are occasions when we have trouble calls that come in that don't align with or aren't part of our network model because of mismatch. And then eRespond is doing that more on a geographic basis of it knows where the lat longs are, so it still works even when your model's not perfect.
Yeah, thanks for that, Mark. I mean, that does draw attention to the fact that we can operate again in various degrees of accuracy of the network model. So in the real world, there's often some mismatches, as you say, and we have designed the system to take account of that fact, and where the accurate information is not there or can't be determined, we'll revert to a more geographical set of rules. But where the accurate network information is there, we can then exploit that accuracy.
Thank you. We have another question. Has LADWP analyzed the return on investment or noted any major immediate benefits for eRespond? Mark, would you like to take that one?
The quick answer is no. Part of the driver of doing the deployment was that we did have Several years ago, we had a mandate from a general manager which said that we must be able to have a single point of contact within the customer center. So that drove us on electric trouble and water trouble to try and put solutions in place that enabled a normal or a regular customer service billing agent to take trouble calls. So we already had a solution deployed that sort of partly solved that problem. So when we came to looking at how to replace the system, part of the functionality we needed to replace was around that. How does the agent take the customer call? We went and then looked at CGI, Oracle, Esri, trying to find, okay, so what solutions are out there? I think the Esri said, well, you could custom build one on top of Esri, or you could go to Trimble, and those were really the only two options we found. We do have, I think, just as a comment, I think we certainly are getting a better understanding now of how our water system is working and what leakages we have within it. I would say 7 weeks into deploying it, I think we're a little bit early in the game to really have got to a point. We're still sort of fighting fires, so hopefully within the next 2 or 3 months we'll get a better analysis of where we are.
Thank you. Next question is, how important is an Esri-based GIS solution to getting eRespond to work? Adrian?
It's not essential. I mean, as an Esri partner solution, it's easier, but it's not essential. We can do that import from any GIS model, or indeed, we've encountered situations where you have a network model that's stored in an asset management system. So we can handle those situations as part of that integration that we have.
Thank you. Okay, can you give more details about the collection of GPS points in the process? Adrian or Mark?
I can talk a little about that. So within our solution, so for example, this is not deployed at LA, but one of the things we do at United Utilities is part of a field survey for flooding incidents. And that does include drawing boundaries of the impacted areas, and also then the restoration boundaries associated. And those are drawn on a map. And if you do have a GPS capable device, you can obviously integrate with that capability on that device.
Thank you.
Mark, I don't know if you want to add anything from an LA specific perspective there.
Yeah, we're working on a couple of things for future of using some GPS devices on some other projects. Also in terms of getting, one of the things that I think was a challenge, or took us a little bit, was getting accurate lat longs for some of the meters that were missing from the GIS system. I think one of the comments we had from our GIS group was, well, we are a couple of years behind on putting stuff in, but nobody's ever complained before. So.
Thank you.
Okay,
we have just a few more minutes, so we'll cover 1 or 2 more questions. If I already have an Esri ELA, how easy is it to add eRespond, and what is the difference between eRespond and the Esri water template? Chris, do you want to take that one?
Sure. Sure, thanks. So I'll let Adrian cover maybe the second part, but the first part, eRespond is Esri partner solution, so it's optimized for customers who have Esri, and it works real nice with an ELA. If you're familiar with an ELA, it's Enterprise License Agreement. So there's small utilities and there's municipal. In the case of City of Los Angeles, there was an existing Enterprise License Agreement that eRespond, the license agreement for eRespond, could layer on top of nicely without any additional implementation costs for licenses on the Esri side. So it's leveraging ArcGIS server and the technology that the City of Los Angeles had already licensed. so I know there's a lot of water and wastewater utilities that have enterprise license agreements or copies of Esri software, and so the design was to be able to sit on top of that seamlessly and work very nicely with that existing investment. The second part of the question, in terms of the difference between some of what's in the water template solutions and the product eRespond, Adrian, maybe you can cover that.
Adrian?
Sure. So without getting into the low-level technical details, I think the key aspects that I would identify as differences would be around the whole business process. So within eRespond, it's an end-to-end business process of incident identification through tracking of the resolution and dispatch. So whereas the templates are much more about data gathering and visualization and being able to render that within the GIS. I think the other difference I would draw attention to would be around the integration landscape within eRespond and the ability to integrate with the various enterprise systems at the utility, again, to facilitate that end-to-end process.
Thank you. Okay, well, that's about the end of the webinar. I do want to tell everyone that this webinar is being recorded, so we will be posting it to our Esri website. We'll send out emails to those that have registered, whether they attended or not. We will also post information online and on the Meetup site as to how to get to the video recording. So thank you everyone for participating, and have a nice day.